Hello guys, how are you today? So today I'll be explaining the chemistry AMS of term 2 week 9. So let's start with the first question. In the first question we have hydrocarbons are organic compounds. Which of the following atoms are the only ones present in hydrocarbons? From their name, they have hydrogen and carbon. So the only two compounds present in hydrocarbons are going to be what? Hydrogen and carbon. We move on to question number 2. They said, which of the following are true about graphite, diamond, and fluorine? We know that these three are only made up of carbon atoms only. Now, the only electrical conductor out of the three of them is graphite, so definitely you cannot choose this. They have the same chemical composition for sure because they're only made out of carbons, but even if they have the same chemical compositions, they do not have the same physical properties. And then finally, they are allotropes, meaning they're made of the same element, they're the same element but in a different chemical composition, so a different format. This is what an allotrope means. So again, graphite, diamond, fluorine, they are all made out of carbon. They have the same chemical composition, and since they have the same chemical composition but different structures, then we call them allotropes. We move on to question number 3. They are asking us about organic compounds. What does an organic compound mean? An organic compound, first of all, needs to contain carbon, hydrogen, and any non-metals. So non-metals. Again, organic compounds should contain always carbon and hydrogen. So carbon and hydrogen are the main elements of an organic compound, and they need to contain as well non-metals. So if you see any metal, we're not going to take it. CH4 is an organic compound. This is not an organic compound because there is a metal. This is definitely an organic compound because it has C, it has H, and it has a non-metal. This is not an organic compound because it does not contain H. And then finally, we have this one over here because it has C, it has H, and it has O, which is a non-metal. So this one and this one. We move on to question number 4. Which of the following are alkanes? What is the general equation or the general structure of an alkane? It is C. Okay, let me fix my handwriting. C, N, H, 2N plus 2. So this is the general format of any alkane. Let us try them. If you have 2 carbons, so it's going to be C2H, 2N, which is 4 plus 2. So it's supposed to be C2H6. So definitely this is wrong. CH4. So C1H is 2 plus 2. So CH4. Definitely this is correct. And then you try for all of them. For example, C3H. C3H. 6 plus 2. So C3H8. This is also correct. 5. Now you could do it mentally. For example, 5 times 2 is 10. 10 plus 2 is 12. So this is also correct, and definitely this is incorrect. So these 3 are alkanes. We move on to question number 5. How are alkenes produced? Now, alkenes are produced in the book. They gave us 2 definite ways about how alkenes are produced. They are either produced by the dehydration of alcohols. So remember that dehydration of alcohols produce alkenes, or the cracking of chains of alkanes. So let's say you have long chains of alkanes, for example, CH4, and remember, alkanes are saturated. What does saturated mean? That means all the bonds in the alkane are single bonded. So let's say it's something like this. Okay, if you break these long chains, it's not a long chain, let me make it a long chain to be more realistic. If you break this long chain, okay, into, let us say, something that is double bonded, then you could produce an alkene. So let's take CH2 bonded to another CH2, okay, bonded to And here, of course, it's gonna be a double bond. Do not forget the double bond. Bonded to, let's say, CH3 to whatever. Let's just say it's something like this. So as you can see, we broke the single bond. We made it a double bond. And this is called cracking. And like this, we would have produced what? We would have produced alkenes from a long chain of alkanes. So the two methods of production of alkenes are by cracking long chains of alkenes or by the dehydration reaction of alcohols. Moving on to question number 6, they said, what is the general molecular formula of alkanes? For alkanes, their general molecular formula is CnH2n plus 2. For alkenes, their general formula is CnH2n. For alkynes, their general formula is C2H2n minus 2. Alright, so for alkenes, we're going to choose this option. Now they said, give the molecular formula of an alkene having 2 carbons. Alkene having 2 carbons, that means it's CnH2n plus 2. So C2H4 plus 2, so C2H6. This is what we need to write. We move on to question number 7. Which of the following is the general molecular formula of alkenes? Again, as we said, alkenes, their general molecular formula is C2H, not C2, my bad, CnH2n. So this is what we are going to choose, CnH2n. Now, they said give the molecular formula of an alkene having 2 carbons, so it's going to be C2H4. So C2H4. We move on to question number 8, which is consider the following compounds. Let us see what is the difference between the two compounds. Let us count. They have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hydrogens. Okay, then 1, 2, 3, 4, 5, 6, 7, 8. So like 4 here and 4 here carbons. So as you can see, their chemical their molecular formula is the same, even though their structural formula is not the same, but in general they have the same molecular formula, which is C4H10. Here and here they both have C4H10. Now, based on the C4H10, we can tell whether it's an alkene or alkyne. By looking, you can see that it's an alkane because it follows this formula CnH2n plus 2. Okay? Now, they have the same molecular formula, but they do not have the same structural formula. It's different. They don't have the same chemical properties for sure. This is like different. They have the same chemical formula, but not the same chemical properties. And for sure, they also don't have the same physical properties. Now, compounds I and 2I. Now, because they have the same molecular formula but different structural formula and different chemical and physical properties, we call these isomers. Okay, we move on to question number 9. They said choose the correct answer to complete the following sentence. Carbon dioxide. What about carbon dioxide? When you pass carbon dioxide on lime water, it turns it milky. Carbon dioxide, CO2, is slightly soluble in water. These you guys should have memorized it. Carbon dioxide is responsible for the fizzing action of soft drinks, for sure. Now here, a dilute acid is added to an unknown sample. A gas is released that turns a clear lime water milky. If it turns a clear lime water milky, then that means the gas released is CO2. That means it contains a carbonate ion. Okay, so the sample contains a carbonate ion. We move on to question number 13. Now here, pay attention. As you can see, all of these compounds, CH4, C2H6, C3H8, are alkanes because they follow which composition? They follow the composition CnH2n plus 2. So they have the same general molecular formula, first of all. They undergo substitution reactions and they have similar methods of preparation. That means they are all alkanes, first of all. Second of all, they're all substitution reactions. And third of all, they have similar methods of preparation. Now, since they're all alkanes, we can say they are all from the same homologous group. or the same homologous series. So if they're all alkanes, then they're all from the same homologous series. All alkenes, same homologous series. Homologous means like they are all the same, from like the same series. Alright, we move on to question number 14. A hydrocarbon contains only hydrogen and carbon. So let us see. This is not an option. Neither is this. Neither is this. So the answer is C6H6. We move on to question number 15. The only saturated hydrocarbons are alkanes. What does saturated hydrocarbons mean? That means in their structure, in their structural format, they have single bonds and they're only made up of single bonds. This is what saturated means. Whereas unsaturated, they don't have all of them single bonds. They have some double bond, some triple bond. Yes, they do have single bond, but you cannot find it all to be single bonds, whereas in saturated, all of the bonds are single bonds. So how do we know which ones are alkanes and which ones are not alkanes? You just know that alkanes, their structural formula is CnH2n plus 2. So you can see this is an option, and this is also an option, whereas these two are not options. These two are what they are, alkenes, because they follow the structural formula of alkenes, which is CnH2n. So definitely these are saturated and these two are unsaturated. We move on to question number 16. Upon adding compound X, the reddish-brown color of bromine water is rapidly discharged. Discharged means it goes or it disappears. Now, what causes the bromine to be decolorized? It's very simply ethene, which is C2. Sorry, not ethene, it's ethylene. Okay? How do you get the name, by the way? I forgot to mention how we get the name. So you should memorize that eth means 2. So there is a table you should memorize. Okay? Let me just get them here. I have them in my notes. So you have meth 1, eth 2, prop 3, but 4, pent 5, hex 6, hept 7, oct 8, non 9, and then finally dec is 10. These you should memorize them. These are gonna be your prefixes, what you put first. Whereas the suffixes are based on what they are. So over here, this follows which structure? It follows the CnH2n structure. So it is, this structure belongs to what? To the alkenes. So you're gonna take the last, the suffix of alkenes, which is "ene", and you're gonna put it with how many carbons it has. It has 2 carbons, so that means it's eth, and because they're unsaturated, we put "il", so ethyl, okay, and then "ene". So this is not ethene, my bad, this is ethylene. Alright, why? Because it has a double bond. The ethylene looks like this. It is a C double bonded to another C, and then you have H here, H here, H here, and H here. So this is pretty much, I over-exaggerated what I was supposed to say. So compound X is the ethylene, so it's C2H4. But it's not only C2H4, it's supposed to be what? An alkene. Because alkenes, they make the color of bromine disappear, which is Br2. Okay? Whereas alkanes, they do not really affect it. We move on to question number 17. They said pentane has the following structural formula. Pentane, as you remember, pent is 5. So we're supposed to have 5 carbons. And it ends with what? It ends with ane. So it is supposed to be an alkane. So it's saturated and it only has single bonds. Now, how do we choose the isomers for pentane? What we need to know is that when you are putting something, or like when you are misplacing a hydrocarbon, You cannot put it on the first one and you cannot put it on the last one, because these are the terminals. So if you put it on this terminal or this terminal, this would not be accurate, because you're not allowed to put anything on the terminals. So if you want to displace the hydrocarbons, you can either put them on this one, or this one, very simply. So definitely we're gonna cross out anything that has it put on the terminals, and that means the ones that are not put on the terminals, here it's not put on the terminal, this and this are the terminals, and this is the center, so definitely we can choose it. We go to question number 18. So chlorine Cl2 is added to methane CH4. Okay, so the chlorine Cl2 is added to methane CH4. Now what happens? The reaction between methane and chlorine can be speeded up by UV light. Remember that alkanes, their reaction can be speeded up using light, any type of light. In this case, it's UV light. This reaction is called what? It is called a substitution reaction, because what happens, chlorine takes the place of a hydrogen atom in the methane. You should remember always that chlorine does substitution, okay, with the what? With the alkanes. So we can make a general rule in that whenever we see an alkane, the only thing it will undergo is substitution. Whereas alkenes, they undergo what? They undergo addition. So whatever you have, you are gonna add it to what is already given. Okay, so they said select the possible products of the reaction between methane and chlorine. Now what's gonna happen is, okay, this is CH4. Okay, because of substitution, the Cl it can replace the H. So what's gonna happen is that you're gonna have a product which is HCl. So one of the Cl's is gonna replace the H. You can have HCl, okay, it's one of your products, and another product is gonna be like, it's out of many variations. So it's either carbon and you have Cl, H, 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 or carbon, you have Cl, Cl, H, H, or then you have carbon again, Cl, Cl, H, Cl, and then you have carbon again, Cl, 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 and Cl. So definitely HCl or carbon with any variation, except like carbon with 4 hydrogens, that's not accepted. So HCl, this, and this. We move on to question number 19. Okay, so question number 19, ethene. C2H4 has the following structural formula. Ethene reacts with hydrogen gas, okay? Ethene is an alkene for sure. So again, as I said before, you can call it ethylene, forgot how to write it, ethylene or ethene. Either way works, but this is the recommended way. If they want it like this in the exam, then yes, you can name it ethene. And please, I do recommend that you name it ethene, because I think this is how the school wants us to name it. So C2H4, which is ethene, you are bringing hydrogen gas. And again, this is an alkene. And we said alkenes, they undergo what? They undergo addition. So we are gonna add hydrogen to the alkene. So this is addition it's undergoing. You're adding hydrogen. So if it was C2H4 plus H2, it's gonna be C2H6. So very simply, it is C2H6. Now, choose the homologous series of the product of the hydrogenation of ethene. Very simply, C2H6 follows which code or which like structure? It follows the structure CnH2n plus 2. And this is what? This is an alkane. So we can say that this is an alkane. Moving on, the correct classification of the product, it is saturated. Why? Because alkanes are saturated. They're the only saturated hydrocarbons. Now, ethanol, C2H5OH, can be produced from ethene under certain conditions. Now, the reagent that converts ethene into ethanol is steam, which is H2O. Actually, you can find it like this. So ethene is C2H4. And this is ethanol, which is C2H5OH. And remember, because it's an alkene, it can undergo addition. So whatever you have, plus let's say it is whatever, we're gonna call it box, it is gonna give you C2H5OH. So in total, you had how many H's added? 2 more H's were added, so H2 and an O. Now H2O, always you have to take it in its gaseous form, so you're gonna take it as steam. Okay, now ethene reacts readily with chlorine, Cl2 at room temperature. Locate the product of the reaction between ethene and chlorine. Now remember, it's an alkene, so it undergoes addition. So with the Cl2, it's gonna do addition. So if it was C2, it was double bond like this, H, 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 and H. And then you add Cl2, so you're gonna have Cl here and Cl here. So definitely this is gonna be our structure. We move on to question number 20. They need unsaturated hydrocarbons. You directly choose the ones that do not have, like a double bond or triple bond. Anything that is all of it single bond is saturated. Okay, now diamond. Okay, what do we know about diamond? Diamond is used for jewelry. It's also used for glass cutters. Graphite, on the other hand, is used for pencils, electrodes, and furnace linings. We move on to question number 22. If the amount of oxygen is limited, always remember limited and oxygen, this is what? This is going to give us carbon monoxide, CO, whereas if it's not limited, then it's going to give us carbon dioxide. So our answer here is carbon monoxide. Number 23, the above reaction is a what reaction? How do we check? We know this is 0, its oxidation number is 0, this is also 0, whereas here it becomes +4 and -4, so this is a redox reaction. Now what happens to the O2? If O2 originally was 0 and then it became -4, that means it's gaining electrons, so it's undergoing reduction, so it is being reduced. We move on to question number 24. Directly, when you see the inverse of photosynthesis, you are going to put respiration. Number 25. Some pieces of calcium carbonate and dilute hydrochloric acid are placed in a flask. The solution effervesces, so there is a gas released, and since it's calcium carbonate, this gas is CO2, and the colorless gas, which is more proof that it's CO2, is released, so the gas is carbon dioxide. We move on to question number 26. They showed us this equation. As you can see over here, we had CH4. You added to it Cl2. Now CH4 is what? It is an alkane. Okay, and alkenes undergo what? They undergo substitution. So definitely this is going to be what? A substitution reaction. And I can't speak today, sorry. And as you can see, it was Cl2 CH4, then it became CH3Cl and HCl because you substituted it. Okay, moving on to question number 27. What does the above equation represent? We have an alkene and you are adding to it hydrogen, so this is an addition reaction, or the addition of hydrogen, which is hydrogenation. We move on to question number 28. Okay, hydrogen gas H2 reacts with carbon monoxide gas CO to produce methanol, which is CH3OH, as shown in the following reaction. Now, when 0.5 tons of H2 reacts completely with CO gas, the amount of methanol produced was 3 tons. So this is the actual yield. Let us find the theoretical yield. So we know 0.5 tons of H2 gas reacted, so divided by 2, you are gonna get 250,000 grams. Okay, so always change it into grams. You're gonna get this much grams. Okay, so if not grams, my bad, moles, so 250,000 moles. If 2 moles became 250,000 moles, how much will 1 mole become? You just do cross multiplication and you're gonna get 125,000 moles. Now what's gonna happen? is you're gonna multiply this number of moles, 125,000, you're gonna multiply it by what? By the molar mass of CH3OH. So it's gonna be 12 plus 3 plus 16 plus 1, so you are gonna get 4 million grams, which if you change it to tons, it is then 4 tons. So to two significant figures, it is 4.0 tons. Now the percentage yield is actual yield, which is 3 over theoretical times 100. If you put it on your calculator, you are gonna get 75%. We move on to question 29. Hydrogen fuel cells work like batteries, but they do not run down or need recharging. Okay. In hydrogen fuel cell, just remember it's only hydrogen and oxygen, and their product is always H2O. Now, finally, a hydrocarbon is 75% carbon by mass. Find its empirical or simplest formula. Okay, very simply, what we are gonna do is we're gonna take 75 grams as carbon, 25 grams as hydrogen, and 100 grams as the hydrocarbon mass. What we're gonna do now is we're gonna divide by their molar mass. Now we got the number of moles, so 6.25 moles plus 25 moles is equal to 100 grams. Now you're gonna divide by the smallest possible value, which is what? Which is 6.25. You are gonna get 1 and 4. So carbon 1, hydrogen 4. That means the formula is C1H4 or CH4. And as you can see, it is an alkane. So very simply, the formula is CH4. Let us submit, and hopefully there are no mistakes. And thank God there are no mistakes. Thank you guys for watching. I hope you enjoyed and have a wonderful day.